So in this first learning target for solving quadratic equations, we're just going to be sketching reasonable graphs, reasonably neat, and estimating the solutions, which are the x-intercepts. These aren't going to be perfect. We're not solving these at this point using the quadratic formula. We're not getting an exact answer, but you need to have a graph that's neat enough to get reasonable estimates. So if I look at the quadratic formula, taking you back to when you did that last year, it's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You need to know that. I could split this apart into the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. The reason I did that was because this part, the opposite of b over 2a, is actually the x value of the vertex of the quadratic equation. This part tells me how much I'm going to shift to the left or to the right to find my intercepts. So when I'm getting ready to graph, I need to find the x value of the vertex first, which is the opposite of b. Well, b is the coefficient of x, so -4, opposite of that is +4, over 2 times a, so 2 times 3, which is 4 over 6, which is 2/3. Now, I expect you to make an xy table with the vertex being the middle point on your table. So 2/3 is my middle x value. I'm going to want to use integers as much as possible though, so I'm going to go down to the next two consecutive integers below 2/3, which would be 0 and -1, and then up to the next two consecutive ones, so 1 and 2. I'm going to plug these values into my calculator and calculate for y. So when I do that, I'm going to take 3 times 2/3 squared minus 4 times 2/3 minus 2, etc. And when I do that, I end up with the following values. Again, I'm going to do that for each of them. So if when x is -1, I end up with a y of 5. When x is 0, y is -2. When x is 2/3, y is -3 and 1/3. When x is 1, y is -3. And when x is 2, y is 2. Now, I don't see the symmetry in those y values that I would see if I was going out the same amount from x in each direction, and we'll see that in other ones. Now, make sure that you are using a straight edge for your lines, because every time you're supposed to do something that's straight, you need to use a straight edge. My y's, I have to go up to +5 and down to -3 1/3. So if I think of this as -4, 3, 2, 1, I could put my x-axis here, probably more neatly than I just did, and I can get up to 5 and down to -3. My x's need to go from -1 to +2, so I might as well just pretty much center my y-axis, and I'll be okay. I'm going to plot those points. So -1, 5, 0, -2, 2/3, and -3 1/3, 1, -3, and 2, 2. Now I cannot draw this very neatly on here. I usually turn my paper to the side so that I can get a pretty good curve. Yours should be much neater than mine is. I'm not even going to estimate these x's from here. I'm going to look back to where I graphed this more neatly on my paper. And I'm going to estimate my x here is at about -1/3. And my x here, my x-intercept here, is at about 1 2/3. So those are my estimated solutions. Are they exact? No. Are they reasonably accurate? Well, if I go to Desmos, I can actually look and see it's about -0.387, so about -0.38, or -0.39, and about 1. So I said about -1/3. That's reasonably close to -0.387. And I said 1 2/3, probably 1 3/4 looking at this would have been closer. but 1 2/3 is at least a reasonable estimate based on my fairly rough graph. Again, your graph should look much nicer than mine. Take a little bit of time to do these neatly enough that you can make reasonable estimates. So, I look at B. The first thing I'm going to do is find the x value of the vertex, which is the opposite of b. And remember, this is ax squared. So a is the coefficient of the x squared plus bx. B is the coefficient of the x plus c. C is the constant. So the opposite of b, the opposite of -5 is +5, over 2 times a, and a is -1. I simplify this and I get -2.5. So I'm going to do my xy table with -2.5 in the middle, going down to -3 and -4, and up to -2 and -1. I plug each of those in for x and simplify, and I get, when x is -4, y is 1, and 3, and -2.5 gives me 3 1/4, and -2 gives me 3, and -1 gives me 1. I do see the symmetry in the y's here, because -3 and -2 are the same distance from -2.5, so their y's should have the same value. What I'm not seeing, though, this thing opens down, but I haven't actually gotten below the x-axis yet. I would expect you to graph 2 more points then. So when x is -5, y is -3. When x is 0, y is -3. That's going to take me across the x-axis to get a better estimate of my zeros. So my y needs to go up to 3 1/4 and down to -3, which means I might as well just pretty much center my x-axis. I need to go from -5 only up to 0, so I can move my y-axis over to give myself room to get to -5 going by ones. So -5, -3, -4, 1, -3, 3, -2.5, and 3 1/4, -2, 3, -1, 1, and 0, -3. Again, I can't draw this very neatly on here. I'm going to do my best. Yours should look neater than this. I would recommend turning your paper to the side. Ooh, that's really not good. Going back to my paper where it is done more neatly, x is -4 1/4, I estimated, so -4.25 for this one. And this one I said is about -3/4, so -0.75. Again, those are not exact, but they're reasonable estimates based on a decently neat graph. So the x value of the vertex is the opposite of b over 2 times a, which ends up being 1. So from 1 in the middle, I'm going to go down to 0 and -1, and up to 2 and 3. I calculate my y values for those, and I get 9, 3, 1, 3, and 9. And I would recommend you calculate those to make sure you got what I got. I need to get up to +9 for y, but I don't need to go to the negatives at all. Now you might say, wait a minute, you made us calculate a couple of extra things in the last one to see where it crosses the y-axis. But notice here's the vertex in the middle. It's going up, so my y's are just going to get greater and greater all the time, which means actually this one is never going to cross the x-axis, which can happen with a parabola. Since part of this is to graph it, though, I still need to sketch my graph. So -1, 9, 0, 3, 1, 1, 2, 3, and 3, 9. This one opens up, which I could tell because this is a +2 in front of my x squared. And since the vertex is above the x-axis, it's never going to cross the x-axis. So my answer in this case is no real, read the real part, solution. In a couple of units, we're going to actually calculate the solutions for this, but they're going to be imaginary or complex solutions. So this one, there's no real solution. So you need to be neat on your graphs, neater than I can do on this, and then give decent estimates, reasonable estimates for the solutions.